Hello my dear students, welcome back to my channel Essential Academy Chemistry with Vinay. In this video, I am going to help you to solve the questions based on hydrogen spectrum or line spectrum. I am going to make this concept very easy for you so that you can solve the questions easily without any problem that is based on hydrogen spectrum. Yes, let us start now. In this video, we are going to learn about the hydrogen spectrum. Hydrogen spectrum. In hydrogen spectrum, children, I will be telling you the first, that is about the chart of the series. For example, it is Lyman series, Balmer series, Pachman series. About that series, the chart I will tell you and how the question will be based on that. And one more, I am going to tell you how to calculate the frequency. How to calculate the frequency in this part of hydrogen spectrum. And I am going to tell you how to solve the question where you are going to calculate the wavelength. To calculate the wavelength, to calculate the frequency that is based on the hydrogen spectrum, and how are the questions are going to be based on the chart of series. We are going to discuss all the three in this video, children. Then let us start one by one. Observe here, children. First, let us know the formula that we use that is oftenly used in hydrogen spectrum. That is 1 by wavelength, that is equal to RH 1 by N1 square minus 1 by N2 square. The RH value, which is known as the Rydberg constant. This equation is known as the Rydberg equation, which has got a constant value of RH, that is 109677 per centimeter. There is one more formula that you need to remember. This RH value is not going to be same for the elements like helium, lithium, beryllium. At that time, you have to take 109677 into Z square, the atomic number of the other ions. So make a note of this Rydberg equation, which is very important to solve the questions based on hydrogen spectrum. With the help of this formula, we can find the wavelength, we can calculate the frequency, and there is one more chart which I am going to share with you right now. Here comes the chart. In this chart, if you observe, children, you need to memorize this chart where it says the name of the series, Lyman series, the N1 value will be 1, N2 starts from 2 to 5. The region is very, very important. The region, if you observe, it is UV, ultraviolet radiation, ultraviolet region. Next, Balmer series, it starts from 2, N1 value is 2. For N2, it starts from 3 to 6. It is going to fall on the visible region. Then we have Pachman series, 3, 4 to 7. Then it is going to be very near to the infrared radiation. Bracket series, 4 N1 value, then the N2 will be 5 to 8. It is going to be exactly towards the infrared radiation region. Whereas P-Fund series, that is 5 is the N1 value, N2 will be 6 to 9, and it is going to be very far away from IR radiations, that is infrared radiations. I hope you have understood this chart, and this chart is very important, children. You have to memorize this chart, the regions where it falls. Children, we have three important questions that is going to be based on the hydrogen spectrum. We are going to solve them one by one, where you will get an idea how to solve them. Let us start with this question. If you observe in this question, children, the first line in the Balmer series in the hydrogen atom will have the frequency They are asking you to calculate frequency. So how to solve this question? Let us solve this question, children. So we already know the formula of this. So what is the formula? We already know the formula, that is 1 by wavelength is equal to RH of 1 by n1 square minus of 1 by n2 square. And here they are asking for Balmer series. In case of Balmer series, what is the n value, children? You can observe here the n value for Balmer series is 2. Whereas for the first line they are asking, for the first line the n2 value will be what? It will be 3. So n1 will be 2, n2 will be 3. I hope you have understood, because in the question they have mentioned it is Balmer series. That is why I am taking n1 as 2, n2 as 3. Hope you have understood this chart and you know the formula now. Let us start with the formula first. I'll just take the formula, that is 1 by lambda is equal to RH, that is of 1 by n1 square minus 1 by n2 square. So before going to this lambda, let me just take this lambda as what? I'll just take this as C is equal to frequency into lambda. Or I can also write this as lambda is equal to C by frequency. Or I can just take this as C by frequency over here, that is 1 by lambda. So if I take it as 1 by lambda of C by frequency, that will become frequency divided by C, that is equal to RH, that is of 1 by, what is n1 value? N1 value is 2 square minus divided by, what is n2 value for Balmer series? I have told you it is 3 square. So next I'll just take this C here, so that it becomes frequency is equal to RH into C, that is into 1 by 2 square is 4 minus 1 by 9. Or frequency is equal to, the value of R is 1097 into 10 to the power of 7 into the value of C. C is speed of light. It has got a fixed value 3 into 10 to the power of 8. That is going to be, if we simplify this whole value, we'll get the value 5 by 30. The next step you can observe, I'll just multiply these two, I'll simplify these two values, where you can observe that we'll get a value 3.29 into 10 to the power of 15, that is into 5 by 30. Children, when we further simplify this value, you'll get a final value, that is going to be frequency is equal to 4.757 into 10 to the power of 14 per second. Hope you can simplify this, and when you simplify the above, you will get this value 4.57 into 10 to the power of 14 per second. It is seen in option A. So A is the correct option. Let us try one more question now. As I have told you before, this question, if you read, which of the following series of transition in the spectrum of hydrogen atom fall in visible region? So they are asking which series which is going to fall in visible region. So this is the question which will be directly related to the chart. So, and this was asked in NEET 2019, children. So I'll just take the table. Here it is. So if you observe here, the visible region is in Balmer series. Therefore, your option B is the correct answer. See children, such an easy question. Just a seconds you can solve this question. Let us go for the next question, children. In third question, if you observe, the wavelength of first spectral line in the Balmer series is 6561 angstrom. The wavelength of second spectral line in Balmer series will be dash. So in this question, they are asking you to find the wavelength. The previous question, the first question which we solved, where I have just showed you how to calculate the frequency. Whereas in this third question, we are going to learn how to find the wavelength. And even here also, we use the same equation, that is Rydberg equation. In Rydberg equation, as I have mentioned, that is 1 by wavelength is equal to RH into 1 by n1 square minus of 1 by n2 square. Because again, they are speaking about the Balmer series of first spectral line. So when I go for this first spectral line, if you observe here, if it is a first spectral line, I am going to take n1 as 2, n2 as 3. If it is, they are asking for the second spectral line. You can observe here, children. You keenly observe, you will understand it correctly. You can observe here the wavelength of second spectral line. At that time, I'll take the n1 value as 2 for Balmer series and n2 value I'll take it as 4. Hope you have understood. For the second here, for the second spectral line, I'm going to take n1 is equal to 2, n2 is equal to 4. For the first spectral line, I'm going to take n1 is equal to 2 and n2 is equal to 3. Hope you have understood this part, and let me solve this question for you all. It's a very easy question. The only thing you need to concentrate and listen. First, let us start with the first equation. That is going to be with the equation of Balmer series of first line. When it is a first line in Balmer series, in first line of Balmer series, if you observe, it will be, I'll be just taking as 1 by the wavelength of the first line is been given. The first line wavelength is given as what? That is 6561 angstrom. So I'll just take that value 6561. I'll take that in meters. That is why I'll take 10 to the power of minus 10. That is equal to R of 1 by 2 square minus 1 by 3 square. Next, I'll just take this as, when I simplify this, it will become 5R divided by 36. How is this 36? This is going to be 4. This is going to be 9. 9 4s are 36. When you cross multiply, it becomes 5R by 36. And now I'll just call this as equation number 1. I'll take for the second line now. When I take for the second line of Balmer series, I don't know the wavelength. I'll just take it as 1 by wavelength, lambda. And that is equal to R into 1 by 2 square minus 1 by 4 square, because it is a second spectral line. And now when I simplify this, it becomes 1 by lambda is equal to, that is going to be, how much it is going to be? When you simplify this, you will get it as 3R, and that is going to be 16. It is 4 and here it is 4 4s are 16. When you take this value, you will get a value of 3R by 16, and consider this as equation number 2. So divide the equation number 1. Divide equation 1 by equation 2. So when I divide the equation 1 by equation 2, you can understand it, children. Clearly you observe and know the concept. Here I'll just take it as lambda. This lambda is spectral number 2, second spectral line, that is equal to 6561 into 10 to the power of minus 10, that is divided by, that is equal to 5 by, I'll just take this 5, RR will get cancelled when I divide it. So 5 by 36 into, when I divide this, 16 will move to the numerator, 3 will come down, that becomes 16 by 3. And This, if we simplify further, I'll just send this 6561 into 10 to the power of minus 10 towards this side. Therefore, it becomes wavelength is equal to 5 by 36 into 16 divided by 3 into 6561 into 10 to the power of minus 10. Hope you have understood till here. Next, when we simplify this value, we will get a value that is going to be wavelength is equal to how much? You can simplify, when you simplify this, you will get a value of 4860 into 10 to the power of minus 10. If you take this in Armstrong, that is going to be 4860 Armstrong. Hope you got this. The value of 4860 Armstrong you can just see in option B. 4860 Armstrong, it is seen in option B. So this is where you solved the question how to calculate the wavelength. If we go for the previous one, in this question we have learned how to calculate the frequency by using hydrogen spectrum, and then we have also done a direct question which was based on the chart. That's it in this video, children. For more videos, subscribe to my channel. I will see that I'll make the concepts very easier, and I'll try to get the complete idea on one concept. What are the different types of questions that you will be asked in the NEET examination? Okay, children, that's it in this video. See you again in my next video.